Hello everybody, welcome to the webinar about creating a digital twin based on PDF P&IDs. My name is Christina Rech, I'm product owner for IntelliPit and also Universal Reporter, and I will show you in the next few minutes how to create a digital twin on top of PDF P&IDs. First of all, I will start with the agenda. So I have a few slides about the creation of the twin. Then I will give a live demonstration about what the user can do once the digital twin is available. Also, I will show a little bit about markup and sketching, and also how this digital twin can be used for plant inspection. Later on, I will also talk about future enhancements that we are going to provide, and I will end with that slide. Okay, let's have a look. What source system can we use for the PDF files? Basically, it's all the common CAD platforms like Autodesk AutoCAD, like MicroStation, like Siemens Comos, but also other applications like SmartSketch, for instance, or even SmartPlant P&ID. And the very good thing about it is that you do not need to spend a lot of time and effort for a real data migration. You can use the existing data in the format as it is and work with the objects of the digital twin. What is also very important is that if you have objects coming from different sources, for instance, some files from MicroStation, some files from AutoCAD, these also can be combined inside UPV in the same way like the 3D models can be combined also if they come from different sources. The PDFs for the digital twin, they reside in a folder, and the conversion is done using a new tool which we are providing. It is called PDF Bit Adapter. And it provides a very easy way of scanning the data that is within these PDFs. And when the data is scanned, we use a config file which has a certain syntax, which is very easy to create. And with this syntax, we are able to identify the main objects by searching for the main text labels. And if they match a certain pattern, then we convert these objects, for instance, to equipment objects, to pipe run objects, to valves, and also instrumentation. So the result that you get is a UPVP file, which within the viewer will end up in the IntelliPit area. So the PDF bit adapter is the first step. And the next step is the UPV Builder, which will allow you to combine a 3D dataset with a PID dataset. But I also want to make you aware that it's not really important to necessarily have a 3D file. You can also work in the digital twin only with examples from the PDF files, and there is no real need to also put in a 3D file. In the builder, in addition to putting the two worlds together, you can also define a mapping table. So as you can see here, with a few statements, it is possible to say that this text, if encountered in the PDF file, will be able to correspond and to link to certain 3D objects. So in the end, it is in your hands how you want to create the combination of the data sets. And a very good part here is that all these statements in the mapping file, they add one to another. So in the end, you could use 3 different equipment name mappings, and the software will go sequentially through all of them. And in the end, you will have all your links available within the package which you are creating. Especially for the PDF files, it is very important to have a possibility to add additional properties. And as far as I know, most of the owner operators or also people who are working on the systems, They have equipment lists, they have pipe run lists, they have valve lists with additional information like pressure, temperature, pipe spec, and so on. And we give you the possibility to use an Excel import plugin. And with this plugin, you can load additional properties into UPV, and they will be visible right away in the dataset which you are creating. Also, it is possible to add additional documents, for instance, data sheets. So you can keep them somewhere on your folder in a relative path to the data package, and then you can associate the PID objects or the 3D objects to such documents, and you will be able to use later on the link in UPV to open and display those documents. Okay, this is now the first slide which shows the result within UPV. So the graphical part will come as it is in the PDF file. The recognized texts, like in this case the P-004B, will be recognized as an equipment, and it will get those two properties, equipment name and task, from the adapter. It will get the additional properties like manufacturer and maintenance information and so on from the SDK that we have used to load, and also the link which allows you to open the datasheet, or the link which allows you to jump to 3D, but I will show you this in a few moments in the live demonstration. What can we do once we have this package completed? We can do a very easy task. For instance, we can search for pumps having a certain manufacturer. Once we find these pumps on the PID, we can very easily use the link to 3D to open them up there as well. So everything that you have within a property can be used to very, very fast find the objects and display them in the viewer, and eventually also create PDF files or screenshots in 3D which correspond to those objects. Another way of looking at data is to use the reporting engine, which is available within UPV. So for both parts, for IntelliPit, but also for 3D, you can define reports, and then you can use highlight functions to jump from the object in the report to the graphical object. And also from here, you have very good possibilities to visualize everything you need within the data package that you are working with. In addition to visualization and to searching objects, we also provide mechanisms and functions to make modifications. For instance, we can mark up on top of the PIDs. So if there is a need to place a safety valve in a certain position, if there is a need to inform other people about renaming objects on the PIDs, we can create markups. And these markups, they can be saved, they can be restored at a later time. And the same, of course, is also valid for the 3D system and not only for the IntelliPit system. If you also want to create new objects and not only markup on the PIDs, you can use the sketching function. The sketching function allows you to work with predefined objects like pipe, circle, rectangle, valve, but you can also create your own symbols and use them within the sketching function, and then you can enhance the graphical information with new objects which are saved in sketches. Everything is saved in the tree which comes with version 6 of UPV, and this tree has the two buttons, save and load. So everything that you design or mark on top of the dataset can be reused at a later time. And also what we are planning is to have the workflow system available to communicate with UPV, which means that instead of saving it somewhere on a server, you can really activate the communication with the workflow system, and then everything will be saved in that system as a centralized place for storage of sketches, markups, screenshots, and everything that you put inside the tree from change point of view. One important topic that I plan to discuss today is the possibility to also do some inspection work on the plant. So here, for instance, I have a screenshot which displays how an inspection point can be configured. This is something that we are working on right now. And also, once these inspection points are placed, we can create reports to print them out to Excel, for instance. We can create, of course, PDFs where these points are visible. And what is very important, we can use the linkage to 3D. So in the end, if this inspection refers to a certain valve, we can also jump to the 3D side. We can add information on the parts in the 3D system, and then we can create a combined documentation and store it, use it later on, send it to other users so that they can work with it. And this is also a functionality of the IntelliPit in combination with the 3D data in Upv. Okay, then I will leave for a moment the presentation, and we are going to have a look at the live data. So you see this is Upv, and I will open up an IntelliPit here, which comes from a PDF file. Maybe before doing that, we can have a short look how the PDFs look like. So here I have my two files. I will open one of them and we can go a little bit closer. So you see everything that has a text on it can be identified and converted if it has the right match to the file that we provide for the text search. And the prerequisite is that you are able within the PDF to search for those texts. And if that is the case, then the result will be as what I'm going to show within the viewer. So in here, I can open the converted file. And as you see, we have a lot of graphical information, and everything that is graphical doesn't have real properties because it's just a line. So it has no real extra intelligence from a symbol point of view and so on. But you do have the possibility, if you like, to change the color. So I can color this one to blue. I could color the pumps to red if I like, and also save this color change eventually. I can revert the colors. And regarding the texts, these have been identified by the adapter. So they are converted to objects. So this one knows that it's an equipment, that it has the name P004A. So these are coming from the adapter. The rest of the attributes that you see here have been added via SDK. And also the linking has been done through the builder so that when I click on this link, the software will automatically go to the 3D site. It will open the corresponding object over there. But of course, it also goes backwards. So if I click on the 3D system to the other pump, I can use the same linking capability to switch back. Yeah. It is also working for multiple objects. So if I click on the two pumps and the vessel, I can find all these corresponding objects on the 3D side. So it's really quite flexible. In addition, remember that we have also configured datasheets to go with the package. So I can also click on this blue information here, and then I will open a PDF file which is in a certain folder, and you can configure these type of links with all the objects that you have if you want to add additional documents to the package. Of course, there is also, let's say, a more wide possibility using the document adapter, and then you can kind of link to all related objects, but that's a little bit of a different story and not part of this webinar. Okay, the next step that I want to show is the use case. For instance, if we search for KSB pumps, I can key in the search criteria. I end up with the information that I have these manufacturers. I can click on the first result, and this will open eventually another file where I can find those pumps. I can use the show in 3D as always, and I see the pumps on this side. I could switch to the next selection and search result, and then I can jump from here to the 3D objects, and this is how I can very easily identify the search objects on both sides in PID, but also on the 3D side. Another way of looking at things is to use the reporting engine. So in the reporting engine, it is possible to work with predefined reports. So I could click on existing reports. I could also build a new report eventually. So if I want to know which equipments do I have and in which drawings are they, and I want to see them all, I can just take these two attributes, and if I click OK, I get the list of objects. And if I want to see where is one of these objects, I can just hit the highlight button and the tool will open the object. And of course, it is easier to work with predefined reports. So I will go again on this button. In this case, I will select a pipe run report. And in the pipe run report, you see that it displays all the list of pipe runs which I have in the two drawings. And if I want to know, for instance, where is the one with fluid P, I can click on this line. I use again the highlight button. It will display the label of the pipe that I have been selecting. And also from here, I can jump to 3D. And in 3D, I will get the pipe highlighted, which refers to my PID selection. And we can give it also another try. If I click on one here on top, for instance, this one or maybe both of them, and I go to highlight, they will display. And also from here, I can go to 3D and I will see the pipe in 3D. And I also have the possibility to kind of highlight and gray out the rest. And then you will get the pipe in this selection mode, and the rest will be grayed out, which is also a quite nice function if you're looking for something. Okay, so now we have seen how we can work with a digital twin based on these PDF PIDs from, let's say, visualization and data search point of view. And now I will go one step further, and I will also modify something on top of the graphic of the PIDs. And the first thing which I'm going to do is I will create a markup. So I want to mark a position here and inform other users that it's necessary to place some safety valve. And therefore, I will open up the markup function. And in the markup function, I can select the color and the line thickness. So if I click here on this dot, it will automatically change the size to 5 and the color to red. And then I have some ways of placing those markups, for instance, like this. I can also place a text. I can put the text here on top, and I can say this should be PSV 300. And if I don't like the position, I can move it. I can also move this one. And then we can go in and we can continue maybe to also mark the exact position where we want to place it. And when we are done, we click the checkbox. And this means the markup is still present, but it's not longer visible. So we could maybe create a second one. For instance, if we want to rename a pump and we need to save this information, we open another markup. We change maybe the color to green and again mark it and write the new text, change to P004C. And once we did that, we can close it. Now we have two markups on this PID. We can open the first one, we can open the second one, and if they would be on different PIDs, the software will automatically jump to the corresponding PID and display the markup on top of that PID. As I already mentioned, there are two buttons to save and load these three objects, in this case the markups. So every user who creates this type of markups, he could save them away and they can be reloaded at a later time. I repeat that it's also possible in future to work directly with the workflow system, which means there will be an integration that is pushing directly the changes towards the system. And from the workflow system, you can automatically open up the viewer, including the markups, the sketches, and so on. This is what we are in the process of developing and making ready for client use. Okay, I will close the markups and I will switch to the next part, which is to show you how the sketching function works. So I'm going to create a PID sketch. The sketch automatically knows as the markup to which PID it refers to. And the sketches, I could go in here, for instance, place somewhere a new pipe. I can decide what color do I want to give it, for instance, blue. And then I can start to work from here, and maybe we make a branch going this way. And we could also use objects from a catalog. So in here, I could choose to place a different pump, maybe put it here in this position. I can also, of course, go back and choose a valve and place it here. And I can select the objects on the markup, on the sketch, and I can also place comments. So for instance, if I want this pump to get a name like P300, I can give it the name. I can deactivate the leader line and move the object to another spot. And this is very easy way to work with the sketch function. But it's also possible to copy existing objects. So in case I want to copy maybe this vessel here, I can select it. I can use the copy function and it will take the complete object and put it in a new position. It will change the color to blue, and then I can just use a line maybe and make the connectivity to that vessel and so on. And this is how the sketch function is working, also across multiple drawings. So if I close this one, I can also close the drawings. And then I can show you that if I double click on the markup, it will automatically open the corresponding drawing and display the markup. If I double click on the sketch, it will automatically also display the sketch. And I can also activate the different markup. And this is done automatically just by double clicking here on the objects in the tree. Okay, now we come to the last part of my presentation. And the last part is that I want to show you how to place these inspection points and what we are thinking about doing in that area. So I will create another sketch. I will call it inspection. And in this sketch, I will change the color to red. And I will place 2 points. One of them here, one of them here next to the valves. And these points, they got some special attributes like inspection point and inspection point description. This is done with custom attributes. So I can key in the number 1 for this one, and I can set it to open. And I could key in the number 2 for this one and set it to closed. And then if I use the drag function, I can take the one and put it inside the point. And in the end, what I can also do is switch from here to the 3D system. And in the 3D system, I can add information via comments to the objects that are related to the PID. So I can drag a comment here displaying the valve name, and I can go back to the files and add a comment here and call it point number 1, open, and then this will also display on the 3D system. And from here, it is also possible, if the user likes, to create a screenshot. The screenshot will be saved exactly like the view that you see here. So if I go to some completely different position in the model, I can very easily visualize the screenshot. It will be loaded and it will display exactly the document that I have created when I placed these comments. So this is what I wanted to show you from this inspection point of view. And now I will revert to the slide and just go to the next one, talking about the roadmap of future development. We are still in the process of working on the text recognition and also performance for microstation files. This is a little bit more tricky maybe than AutoCAD or other file types. We will enhance the connectivity between IntelliBit objects and 3D objects. So for instance, if you find 10 lines which are stretching across 3 PIDs, you could automatically visualize all the 3D objects without having to change from one drawing to another. So things like that, this is what we are thinking in this area. We also want to enhance the SDK plugin so that you can load additional attributes from your external sources. This is especially important for users who are working with PDF PIDs within UPV. And also we plan to create an inspection module which would allow you to place inspection points on the PIDs and also on the 3D side, so that these points are kind of communicating with each other and reading properties one from the another, so that it's not necessary to key in something twice that you already have used on one side. And also we will make it easier to create these inspection documents, the PDFs from the PID that go together maybe with screenshots from 3D and things like that, maybe a little bit similar like what you know from the double-sided ISO.